In the overview of glycolysis, we noted that the end product pyruvate must be used up and the NADH must be reoxidized in order for glycolysis to continue. If the cell is functioning under aerobic conditions, NADH will be reoxidized and the pyruvate will be completely oxidized by aerobic respiration. Under anaerobic conditions, however, different types of fermentation reactions accomplish these purposes. Fermentations are catabolic reactions that occur with no net oxidation. Pyruvate, or an organic compound produced from pyruvate, is reduced as NADH is oxidized. We're going to look at the two major fermentation pathways, lactate fermentation and alcohol fermentation. Lactate fermentation is familiar to anyone who has performed strenuous exercise. If you exercise so hard that your lungs and circulatory system can't deliver enough oxygen to the working muscles, your aerobic or oxygen-requiring energy harvesting pathways are not able to supply enough ATP to your muscles. But the muscles still demand energy. Under these anaerobic conditions, lactate fermentation begins. In this reaction, the enzyme lactate dehydrogenase reduces pyruvate to lactate. NADH is the reducing agent for this process. As pyruvate is reduced, NADH is oxidized, and NAD+ is again available, permitting glycolysis to continue. So you can see that pyruvate is reduced to lactate by the addition of hydrogen atoms, and NADH is oxidized to NAD+ by the removal of a hydrogen. The lactate produced in the working muscle passes into the blood. Eventually, if strenuous exercise is continued, the concentration of lactate becomes so high that this fermentation can no longer continue. Glycolysis, and thus ATP production, stops. The muscle, deprived of energy, can no longer function. This point of exhaustion is called the anaerobic threshold. A variety of bacteria are able to carry out lactate fermentation under anaerobic conditions. This is of great importance in the dairy industry because these organisms are used to produce yogurt and some cheeses. The tangy flavor of yogurt is contributed by the lactate produced by these bacteria. Unfortunately, similar organisms also cause milk to spoil. Alcohol fermentation has been appreciated, if not understood, since the dawn of civilization. The fermentation process itself was discovered by Louis Pasteur during his studies of chemistry of winemaking and the diseases of wines. Under anaerobic conditions, yeast ferment the sugars produced by fruit and grains. The pyruvate produced by glycolysis undergoes two reactions of the alcohol fermentation. In the first reaction, pyruvate decarboxylase removes carbon dioxide from pyruvate, producing ethanal, or acetaldehyde. In step 2, alcohol dehydrogenase catalyzes the reduction of ethanal to ethanol, and more importantly, the oxidation of NADH to NAD+. The regeneration of NAD+ allows glycolysis to continue, just as in the case of lactate fermentation. The two products of alcohol fermentation, then, are ethanol and carbon dioxide. We take advantage of this fermentation in the production of wines and other alcoholic beverages and in the process of bread making.